Welcome to the Battery Testing Mentor podcast. My name is Johannes, and here I discuss all topics around battery testing and battery safety. Short, on the point, and with practical advice. Also visit www.batterytestingmentor.com and sign up there for the email update. With every episode, I send out the key takeaways straight into your inbox. And if you have any questions, comments, feedback, just hit reply on this email and you directly reach me. Today, I want to spin the topic from last time a little bit further. Last time we talked about the thermal runaway. Today, I want to talk about hazard levels. The hazard levels is basically a classification of the reaction of a cell in an abuse situation, and it is very widely used. It is basically, again, targeting the cell level, and there are 8 different hazard levels. It reaches from 0 to 7, and initially it was defined by UCAR, an association for electric vehicles, and we go together now through these 8 hazard levels. So let's start with hazard level 0. The 0 hints already to that there's nothing happening, which is always good if you use the battery outside its operation conditions, right? So it really means there is no hazard, no effect, no damage. The cell can be used afterwards as it was before, which is also a tricky point because you can't really look into the cell. We come to this now in the next hazard levels as well. But basically, hazard level 0 means you bring the battery like outside the operation and then go back, and basically everything is like it was before, which is by definition not really possible, because if you have taken the battery out of the operation condition, you normally have triggered some problem inside. Otherwise, it would be still in the operation condition. But where this really comes into play is if you kind of overcharge the cell a little bit, couple of tens of millivolt or so, where you are still basically in this safety barrier that the cell manufacturers, for example, designed, and you do this a little bit and go back, then typically nothing happens, and you are just in the safety margin. Then comes hazard level 1, and hazard level 1 is already some defect. I mean, it's not really a defect. It says passive protection device is activated. Passive protection means it's not the BMS, like BMS would be an active protection device that it notices, oh, the cell went over voltage, I need to switch off the battery. But it means there is some element inside the cell that stops the reaction, for example, stops the operation, stops the current, and shuts down the cell and brings it into an good state. For example, an CID would be such a thing. Typically, it is also considered that it is not reversibly. Like you need to really fix it, check it. You need to repair it in case it is repairable. Normally, if you have a cell, it's so densely packed together that you can't like open it, change something, and start using it again. But yeah, there is a passive protection device activated. Then let's go to hazard level 2, which is defect. Defect means something inside chemically is gone bad. Typically, if you start the thermal runaway and you have an slight decomposition of the solid electrolyte interface, for example, you have a defect and you cannot easily like just switch it off and then everything is gone okay again. The tricky thing now about hazard level 0, 1, and 2 is that there's something going on inside the cell. And if you have the cell, you can't just look inside, open it, and say, the chemistry is still fine. This was just an protection device activated. It has a level 1. You need really very sophisticated tools or a lot of testing afterwards to determine if the chemistry, for example, has been damaged. Yeah, and it doesn't get easier. Next comes hazard level 3. And here I combine it with hazard level 4 because both have in their definition the term like electrolyte leakage inside. Hazard level 3, according to UCAR, is leakage, and it says defined by less than 50% of the electrolyte goes out of the cell. Hazard level 4 is venting, and it is defined by more than 50% of the electrolyte goes out of the cell. There are two things. One, it's very hard to really measure. I mean, you can measure how much weight loss there is after the test, like how much the cell was before, how much weight it was afterwards, and then you have the difference. What is very difficult to assess is how much electrolyte was there. There you need to trust the numbers from the manufacturer. Either you are the manufacturer and you know it exactly, or you get a paper and it says there's so much electrolyte inside, and then you have to trust it. The other tricky thing is venting and leakage is something very different also from the looks. And a cell can leak all its electrolyte without venting. And then, according to this definition, it would be defined as hazard level 4 and a venting because it's more than 50% of the electrolyte. Um, if you have seen tests already, you know that there is really also a difference visible, like a cell that opens and then kind of the electrolyte leaks out. It runs over the out of this vent, and you see really this fluid going out is something completely different than a cell where the vent opens and you see this white fog coming out, which is the normal venting. So it is a little bit tricky. It's especially if you do not have reliable information, it is very hard. So after hazard level 4 comes 5 and 6. We bring it together because there is now the next tricky thing about this hazard level definition. I mean, first, the difference between 3, 4 and 5, 6 is that now really something is happening. It's not only some smoke, some fog coming out, but this is really where fire starts, where the cell breaks open. And now the tricky thing is that there are two hazard level definitions. Good thing is one is most widely used, and that is the one according to UCAR, and I referred to before already. UCAR says hazard level 5 is fire and flame, and hazard level 6 is rupture. The SIE hazard level, which is adapted from UCAR, just mixes it up and turns it around and says hazard level 5 is rupture, hazard level 6 is fire and flame. It is a little bit confusing, and therefore just make sure you always know according to which standard the hazard level definition is used. What is now fire and flame? It's pretty easy. Fire and flame is when there is fire happening. It doesn't need to be fire coming by itself. It can also be fire with a spark source, like some external source that makes the venting gas, the fog, start a fire. So basically, it's some kind of definition that it is a combustible gas, that you have these high concentrations in the air. And then the term rupture means that the cell opens at one point outside the vent. Like if the vent opens, it's normal, it is then this venting, but rupture really means the cell opens up at a point that is not designed to open normally. And then we have the next hazard level, the hazard level 7. The good thing is it is the same in these both definitions according to SAE and UCAR. It is the explosion. But again, it's a little bit hard to differentiate between rupture and explosion because like that really a cell ruptures, that it opens up. You need a lot of force. If you like take the pouch cells now out, that you really have an opening. You need a pressure buildup so big that the case is not strong enough anymore. This hazard level 7 is also the highest of these hazard levels. So you have hazard level 0, nothing, hazard level 1, passive propagation activated, hazard level 2, defect, damage, hazard level 3, this leakage, hazard level 4, venting, hazard level 5, fire, flame, hazard level 6, the rupture, and hazard level 7 would be the explosion. One thing that if you go this number through, you immediately think of is that it is some kind of process, some one step after the other. And that is important. That must not be the case. It is some kind of ranking. So normally, of course, you first have nothing and then you have a more and more heavy reaction. And to be honest, the higher the number, the more heavy the reaction is as well. But it doesn't mean that to get to hazard level 6, you need to go through all these steps from 0 to 5 before. I have seen cells that just explode out of nothing if you overcharge them. I've seen cells that, vent and then suddenly rupture, and you have a huge kind of, everything out of the cell in the room. There are cells that, where the rupture comes before the fire. It is always an very unique behavior of the cells. Nevertheless, the good thing about this hazard level is that it makes it really comparable. And you lose a lot of details. That is really the case. Shit. So why this mix up? I don't know, to be honest. It is, from my point, an sacrifice you need to make it comparable. These hazard levels first have been defined long time ago. I once heard it was in the 90s already, where batteries were at a much earlier state of development. But then also it helps to kind of classify the reaction. And with classifying the reaction, you lose some details to have just these 8 boxes where you can put the result in. And that helps enormously when you compare cells with each other. Because then you can say, okay, this cell tends to just react in this hazard level 3, 4. The other one is pretty bad and goes into the explosion. And it's always like this. If you make it easier, if you simplify something, you lose detail. But this is an reasonable thing to do. And to be honest, this hazard level classification has been established so well now that it will be used, I guess, for the coming years, because everybody has really focused their attention on these hazard level classification. Even though like this hazard level classification is targeted to cell level, it is a reaction on the cell level. It is used for packs now as well. And even in packs, you have a much bigger variety of reactions, to be honest. But still, this hazard level is the first way to go when you assess packs as well. With this, I hope I gave you a good insight into the hazard level classification. I look forward to hearing you, seeing you next week here at the Battery Testing Mentor.